Okay, so this is a printed circuit board design that I made, and you can see there the green and the red. Those are all traces for the board, and once you have all of that put in place and you're happy with your traces and all of your ERC checks come out fine, you have no conflicts, then you move on and then you take a look at what the board is going to generally look like when you're done. You can take a look at the board in 3D and it's going to give you a good estimate of how it's going to look when you put it all together and it's finished and it's done. So going into the next part of this process, after you go and you order your PCB and you get it back, well, then now you are going to assemble it. So this is me assembling my PCB design, this PCB design here, and this is sped up 10 times. So this is a long drawn out process of soldering many points just for this design itself. Now, it is still a very good idea to do this, even though nowadays the vast majority of this is automated. You really don't have people soldering as much anymore as they used to. If they solder, it's to correct things, or to change out a part here and there. But for the vast majority of cases, it's automated these days. And the PCB companies, they actually offer you to do this for you. They say, do you want us to assemble your PCB for you with the parts on it, and do the soldering, because they offer that service. And that's a good service, so you're going to pay some more money for it, but it's a good service. And going forward into the future, I may opt to do that. But at a minimum, I think it's very important to actually know how to do this for yourself. And this is through-hole technology, so you can do this for yourself with the through-hole technology, and you can also do it for yourself if you have the surface mount technology, although it is more difficult with surface mount technology. Now, if that surface mount technology has your parts on what they call a BGA, a ball grid array, which means that the solder points are underneath the chip that you're soldering, then that becomes very difficult for a human to do. And you can do it, but you're going to need some special equipment to do it. You need something like a soldering heat gun, and you're going to have probably some more special equipment to make sure that you align the chip correctly even before you apply heat to the chip, and make sure that you don't overheat the chip. When you go to liquefy the solder, you want to make sure that you don't overheat the chip, that sort of a thing. And you can do it, but it's best left up to automation these days. With that being the case, if you have a ball grid array design or a ball grid array component to mount and put onto your board. So I say for that reason, it's definitely worth getting the factory to do it for you. Your factory of choice, whatever factory you chose to manufacture your PCB design for you. Of course, you could also do like how I'm doing here and just stay with through-hole technology designs, and in that way you can do your own soldering for yourself. This is good if you don't want to spend too much money. You want to minimize the amount of money that you spend. You're building a prototype. Your design isn't too big, then you can go ahead and do this, and you tell them, just send me the PCB and don't worry about mounting and soldering any of my parts for me. And so this is good experience for a designer, because then now you know what all it takes to put the design together, and that's automatically that's going to make you have a conception of efficiency, and you want to make your designs efficient. So again, this is sped up by 10 times. You may not be able to do this in a day. It depends on the complexity of your project, how large your design is. So after you're done and you clean up the board really well and you check over everything, then next, this is the finished product. This is what it looks like, and there are more steps to this, but your finished product you're going to put into your enclosure, and then you're going to mount everything that's external to it, to that enclosure, and then you're going to solder everything to the board that comes, external to it, that needs a connection to the board as an interface. Now, here's a demonstration of the product in action. This is what it is as a final outcome.